All right, so here we go. Are you able with tables? We're going to be looking at investigating exponentials. More specifically, we're going to be looking at A and B in the exponential equation and see what they do or what they represent. All right, so here we go. Up at the top of your paper, it says that we're going to be looking at the basic form of an exponential function, which is f of x is equal to a times b to the x power, where a and b are some constant, some number. So what we're going to do is we're going to find out what kind of effect does a and b have on the table. So here's how we're going to do that. First of all, if you look at number 1, A is going to be this number right here, the 3. So put that for me on your paper. B is the number that has the exponent on it, and that's the 2. So A is 3, B is 2. What we're going to do is we're going to take a look at the table of this function y equals 3 times 2 to the x power. All right, so go to your calculators for me. Let's go to y equals, and let's type in that function 3 times 2 to the x power. And go to your table. We're going to fill out this table simply by looking at our calculus. All right, so Samantha, help me out. What do you see next to 0? A 3. What else do you see, Samantha, underneath that 3? 6. Keep going, Samantha. 12, 24, and 48. All right, so this is the table we see on our calculator. Right next to that, what we want to do is identify the ratio, or what kind of pattern do we notice here in the y values. Notice we went from 3 to 6, then from 6 to 12, from 12 to 24, and 24 to 48. What are they doing to the y values? All right, very good. What we're doing here is we're multiplying by 2. In other words, 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. So all we were doing is multiplying by 2. We call that the ratio. All right, we're going to do some more investigating. We'll come back to that here in a little while. Let's go to number 2. Do the same thing. Now notice the A on number 2 is not 3, but a 2. Okay, this first number is our A. B is the number that has the exponent on it. That's this 3 right here. So A is 2, B is 3. Let's take a look at its table. Go to your calculators again for me. Go to y equals and type in the function 2 times 3 to the x power. All right, Gary, help me out here. What does the table look like? What do you see next to 0? 2. 2. All right, keep going. 6. 6. 18. 18. 54. 162. Y'all agree with that table? All right. So, now that we have the table, let's look for a pattern here. What kind of ratio do we notice? What are they doing to the y value this time? Multiplying by 3. All right, so very good. This time they're multiplying by 3. Remember, we're looking for a pattern here. We'll come back to this one again here in a second. Now, if you start to notice something, just keep it to yourself. We're going to see if the rest of us can pick up on it here in a little while. All right, number 3. Number 3, we have the equation y equals 6 to the x power. Now remember, right now we're looking at the basic form of an exponential function, and that form is a times b to the x power. Now, even though you don't see it, there is an a. What is the a? It's invisible, but there is a number in front of the 6, but a 1. So write that down for me. A is 1. B, of course, is the number that has the exponent. In this case, that's the 6. So A is 1, B is 6. All right, so go to your calculators and let's see what the table looks like this time. All right, Alexander, help me out. What are our y values? What's the first y value? Huh? Right next to 0, you see, did you get it in? Go to y equals and type in 6 to the x power. 1, okay. The next y value, 6, keep going. 36, 216, 1296. All right, so this is the table we get this time. So again, let's go over and look for the ratio, or what is it that we're multiplying by this time? Can you see it? What are we multiplying by? 6. We're multiplying by 6. Remember, we're looking for some kind of pattern here. So, if you see it, don't say it yet. Keep it to yourself. We're going to keep going a couple more here, and then see if we can spot what kind of pattern we notice. All right, number 4, A. What am I going to write down for A? What number? 8. Very good. And B is the 0.5. Okay, let's get the table. Go to your calculators. Type in that function. And what do we get for our y values this time? 8. 4. 2. That makes 1, sorry. 1. And then 0.5. All right, so this is what our table looks like. Ratio. What's the pattern this time? Notice we are multiplying by something. What are we multiplying by? What is that? 0.5, which is the same thing as 1/2. So what we're doing this time is we're multiplying by a 0.5. That's why the numbers are getting smaller this time, because we're multiplying by 0.5. All right, I'm going to do 2 more, and then we're going to start to see if we can recognize some kind of pattern. Again, if you see it, don't say it. Just hold on. 5. A. What number am I going to write down for A? 100. B. What is our B? 0.5. All right, so here we go. 0. What are we going to see next to 0? Put that in your calculator. Everybody got it? What are we saying? 100. The next number you see is 50, 25, 12.5, and 6.25. So again, let's come over here and find the ratio. We're trying to find what is it that they're multiplying by. So, what are we multiplying by this time? 0.5. We're taking half of each of these numbers. Half of 100 is 50. Half of 50 is 25. That's what we're doing when multiplying by 0.5. All right, stop. Everybody look. Don't touch your calculators anymore. Stop, stop, stop. We got one more to look at, number 6. But before we do number 6, I want you to look at the ones that we've done so far. What we're looking for is some kind of a pattern. So look, look, look. And let's see if we can see some things here. Number 6, of course we know A is 200. We know that. We know B is the 0.8. So, without a calculator, can you guess what would show up next to 0? 200. Where the heck did you get the 200 from? The A. Is that what happened on all the others that we've looked at? A is always that first number right next to 0? Yes. Okay. Let's see if we can recognize some other patterns. This ratio over here. Y'all think you know what the ratio is going to be before we would put in the calculator? 0.8. We're going to be multiplying by 0.8. How did you know that? That's the B. So, if you look at all the other ones that we've done so far, was the ratio the same thing as our B value? Yes. Okay. The Y values. I know what the first one is. That second one, of course, we can find those by multiplying by 0.8. But before we do that, can you tell me, are those numbers going to get bigger or are they going to get smaller than the 200? Smaller. The Y values are going to get smaller. So let's go ahead and find the rest of the Y values. All right, so let's go to the calculator. We already know 200 is the first one. What would be the next one? Use your calculator. 160, very good. 128. 102.4. And 81.92. So notice there's some things that we can tell about the table simply by looking at the equation itself. We can tell what our value next to 0 is going to be. We know what the ratio is going to be simply by looking at the equation. And we can tell whether the numbers are going to get larger or smaller based on the ratio or our B value. All right, so that takes care of the 6. If you look out to the right-hand side of your problems here, of course, these are the 6 that we've already done. These are the answers that we came up with. A. Where does A value show up in the table? Where do we always see that A? Next to the 0. All right, very good. Write that down. We always see A right next to the 0, which means we're always going to end up with the ordered pair 0, and then whatever A is. So A is always going to be next to 0. Yes, you can rephrase that so that it makes sense to you. Yes. A is the number next to 0, which means we're always going to end up with the ordered pair 0A. By the way, anytime we have an ordered pair 0 something, what does it represent on our graph? Where is it on our graph? 0, let's for example, a 0, 2. What? No. There it is. It's the Y, what do we call that? Y-intercept. All right, so let's include that as well. Okay. 0, A is going to represent our Y-intercept. All right, so that's the A. What about the B? What effect does B have on the table? What do we notice about B? There it is. It's the number that we're multiplying by. So B is our pattern. It's what we're multiplying by. Or they use it's the ratio. It's the number that we're multiplying by as we go down those Y values. It's our pattern. On number 1, our pattern was multiplying by 2. On number 2, our pattern was multiplying by 3. And so our B just represents our pattern, or what we're multiplying by. All right, so that takes care of the first page. Let's take a look at the second page up at the top. Let's go ahead and summarize what we've just found out. For the function of the form y equals, or f of x equals a times b to the x power, a is going to be what we call the initial amount, or our starting value. The initial amount, or if you prefer, starting value. As we said earlier, it's what we see next to 0. Notice there we also included is the y-intercept, just like we said earlier. So it's the initial amount. It's what we start with. It's right next to 0 in the table. It's the y-intercept. That's what A is. What did we say B was? The ratio, or the pattern, or what we are multiplying by. Okay, so there's a couple of different ways that we can phrase this. It's the ratio. It's what we're multiplying by. It's our pattern. Now, if you look back at the tables that we filled out, you'll notice that sometimes the y values increase, but sometimes the y values decrease. Let's see if we can tell when each of these is going to happen. So, the y values increase. If you look at the front of your paper again, notice there's a couple of them where the y values increase. And there's a couple where the y values decrease. How are we going to know which is which? How do we know when they're going to increase, and how do we know when the y values are going to decrease? What can we look at? What's that? The ratio number. And ratio number is what? The A or the B? The B. So we can look at B. And what exactly are we looking for in the B? What are you noticing? Okay, so when it's greater than a 1, what's happening? It's going to go up, or the numbers are going to get larger. When are they going to go down? When it's less than 1. All right, so let's take a look here. The y values are going to increase, and your B is a number that's greater than 1. Like the 2, the 3, the 5, and so on. Anytime we got a B value that's greater than 1, those y values are going to increase. They're going to get bigger. Now, the y values, if those y values are decreasing, what does it say about our b? It says that it's, what did y'all say? Less than 1. But we need to be careful here, because if I say b is less than 1, that would also include some negative numbers. And right now I don't want to include the negative numbers, I just want positive numbers. So we're going to say any b value that's between 0 and 1, any b value that's between 0 and 1, would give us y values that are decreasing. So numbers between 0 and 1, that's kind of like, let's see, we had a 0.5, we had a 0.8. Those are numbers between 0 and 1. All right, so this is what we have found out about our A and our B. So now that we know this, we should be able to go the other direction. So let's take a look here. Don't touch your calculus, just look up here, guys. Number 7. Notice all they did was give us a table. And we're going to see if we can come up with the exponential equation based on that table right there. Well, what did you tell me about A? A is our what? Our starting value. Where are we starting in the table here? Number 7. What is next to 0? 5. So 5 is going to be our A. So let me put that right here. 5 is A. What did we say B was? It's the ratio. It's what we're multiplying by. So, over here, can you tell what we're multiplying by? 4. Notice what we're doing over here is we're multiplying by 4, which means our B, our ratio, is a 4. So what are we going to end up with for the equation? Y equals 5 times 4 to the x power. Let's just double check that and make sure it's right. Go to your calculators and let's type that in. 5. Now notice this time they use parentheses instead of the times, and that's okay, it's the same thing. Times 4 to the x power. Let's just double check our table and make sure it matches up with what we see here. The same thing? Alright, very good. Number 8. Number 8. See if you can come up with the equation for me on number 8. Look at the starting value, look at what's next to 0, and then see if you can come up with the ratio. Write that down. All right, let's see what you guys came up with. A, what's our starting value? 2. It's what we see next to 0. That's the first part of the equation. Now we need B, the ratio. What is it that we're multiplying by this time? 9. So B is 9, which means our equation should be y equals 2 times 9 to the x power. How many of you got that? All right, very good. Number 9. Let's do the same thing with number 9. Number 9 is going to be a little bit trickier here. A, what are we going to use for A? 16. That's our starting point. That's what we see next to 0. Where it's going to get a little trickier here is finding the ratio. Now, number 7 and number 8 were pretty easy. It's pretty obvious on number 7 that we're multiplying by 4. On number 8, it's pretty obvious that we're multiplying by 2. But not so obvious on number 9. So let me give you a little help here, guys. Everybody look up here real quick. Number 7. We said that we were multiplying by 4. Here's how you can also get that 4, if you can't see it just by looking at it. What do you get when you take the second y value divided by the first y value? 20 divided by 5 is 4. Look at number 8. 18 divided by 2. What's 18 divided by 2? 9. It's that ratio. Okay, so let's see what the ratio is on number 9. What's 24 divided by 16? 1.5. So guess what we were multiplying by? 1.5. So that's our B. So that means that's what we have right there. All right, do the last one all by yourself. See what you get. By the way, can you tell, look at the y values. Are the y values getting bigger or smaller? Smaller. So what do you know about your ratio? What kind of numbers are going to be? It's going to be a decimal. It's going to be something between 0 and 1. The numbers are getting smaller, so you should end up with something between 0 and 1. All right, what are we going to get for the equation? Y equals 500, and in parentheses, what? Point what? 0.4. That's our ratio. We're multiplying by 0.4. All right, very good. Now, just to wrap things up over here to the far left side, it says here, think about it. Complete this table. We've got y is equal to 4 times 1 to the x power. Without a calculator, just real quick, guys, what would be our starting point? What would we see next to 0? 4. But that's our ratio. That's our pattern. So what would be the rest of the y values? 4. Because you're doing 4 times 1, 4 times 1, 4 times 1. So all of these would end up being 4. Look at the next one. Now, the next one, let's go ahead and put that next one in our calculator. Y equals 4 times negative 2 to the x power. Put that in your calculator and see what we get. All right, what are our y values? You get a 4, I know that much. What else? Negative 8, 16, and negative 32. So these are the y values we get for that section. Now, we got a problem with these two equations here. First thing you notice on this last one that we did here, it goes from a positive number to a negative number, then back to a positive number, then to a negative number. So we got all kinds of things going on. We're jumping from a bigger number, then to a smaller number, then to a bigger number. Can't have that. You see on all the other ones that we've done, the y values are either getting bigger or the y values are getting smaller. We're not going to jump from one to another and another, okay? So that's the first thing. The next thing, if you look at that first one that we did, what do you notice about the y values there? They're all the same, which means instead of having an exponential, we're ending up with a linear function. We're going to get a straight horizontal line. And so it's no longer exponential, let's say linear. So down at the bottom it says, why do you think we usually don't use these values for b? And here's what I want you to write down, and that it's not useful in our problem situation. Not useful in our problem situation. So we're not going to use 1 for the b, because that would give us linear. And we're not going to use a negative for our b value here. And that's because then we'll have y values all over the place. We'll have positive, negatives, and so on. All right, so that wraps it up.